See, so it all does kind of make a little bit of sense. So 111 in octal is 73, and that's turning this octal into binary, gives you this in decimal, same as writing it down as I did here in octal, which is the power of 8, working it all out gives me 73. So obviously it does make a little bit of sense, all this. Right, let me get my pen back and we'll do some more. Right, so let's do octal again. Octal 111, and we'll do hexadecimal 111. So here we go. Right, as we saw, 0, 0, 1, 0, 0, 1 and 0, 0, 1 is your octal, and we're going to now do this one. Now hexadecimal is to the power of 16, so as we did with it, this one we need 8 digits, this is now going to need 16 digits, and the same as before, 1 times 16 is 16, 16 times 16, I am not great with my mental math straight away, so let's do it quickly. Times 10 is 100, times 6 times 5 is going to be 80, and then put out a 16 to the end of that, so 6, 8, 9, 15, 256. You'll notice that all these numbers are pretty similar in that, you've got 1, 2, 4, 8, 16, 32, 64, 128, 256. Notice again, all these numbers do all come out together. That's one of the great things about science and maths. So let me get rid of those old numbers. There we go. Right. So 256, and then times 16. 256 times 16. We'll do it again. 256 times 10 and times 5 is 1, 250, 30, 6, 11, 14, 5, 6, 7, 8, 2, 3, 3, 8, 4, 0, plus it needs another 256, doesn't it? 6, 4, 9, 8, 10, add the 1, 4, 496. If you do binary and keep going up and up and up and up, you'll also see that matches as well. So I'm guessing if I do 1, 1, 1 in hexadecimal, I'm hoping it's going to be 256, 16 and 1. I'm hoping that hexadecimal is going to be 1, 16 and 256, which will give me 6, 12, 13, 5, 6, 7, 273. We'll soon find out, eh? So we'll just, right, no, 273, let's all remember that one. 273. Get rid of all the numbers here. Right, we'll write it up here, 273. Right. So as this one was 0 all the way to 7, giving us 8 digits, this one is 0 all the way to 15, giving us 16 digits. Now, one thing you've got to remember here is that this here is 16. Each one of these digits you've got to try and represent up to 15 in one single digit. It's not too bad with 8 because you've only gone up to 7. You've got to try and represent that in one digit. Well, obviously you can't. So what we'll do, what Octal does, it has 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and then it uses the alphabet, which is A, B, C, D, E and F. It only needs to go to 15. Now, so here we've got 10 digits, and here we've got 6. 1, 2, 3, 4, 5, 6. Equaling goes 50. Equaling out, yes, equaling out 16. So, additionally, old school, these were represented on calculators, and that's what you'll see around. So you'll get A, B, C, D, E, oops, did it? D, E and F. Right. So there you've got A, B, C, D, E and F. So they can be represented on a calculator. Now we've got liquid crystal displays, etc, etc. You can represent graphics and all sorts of different things. Old school though, that's how they would represent it. So I'll write these down again. So we'll write C, D, E and F. Right. So let's move on. So we want to try and represent 1, 1, 1. So we need 4 digits to represent 15 in binary, which is, again, we'll draw it 1, 2, 3, 4. I'll fill in the zeros. That make more sense. 4, 5, 6, 7, where we were before. And we forgot zeros, didn't we? So there's 0. 0, 1, 2, 3, 4, 5, 6, 7. And then, but we're stuck now, so we can't go any further. So we need to move up to 8. So this is why we have 4. You have zeros all down the front. And then we can go to 8. 9. 10. 11. 12. Oops, stupid man. 12. 13. Oops, I've done something wrong here, haven't I? 7, 8, 9, 10, 11, 12, 13, 8, 12, 14, no not 14, and squeeze them on there, 15. Right, let me go back a bit. So that's 15. So you know that if we've got 4 ones across in binary, it's now going to represent 15. I don't think I'm going to get far enough back on this. Right, so we can ignore all that for a minute. Right, so represent 1. Well, it's easy. 0, 0, 0, 1. We'll represent another one. 0, 0, 0, 1. And another one. 0, 0, 0, 1. Right. But let's write these in a long line. 1, 0, 0, 0, 1. 0, 0, 0, 1. Right. Now, if we take this as a stream of binary, we can count them up. 1,